Hi, welcome to this introduction to the quadratic formula, and the first thing that we're going to discuss is a part of the quadratic formula which is called the discriminant. So before we get into what the discriminant is and how do we use it, let's go ahead and talk a little bit of why we need to know the quadratic formula. Okay, so the quadratic formula is needed when something interesting happens when we're solving quadratics. So let's say that we have an equation to solve, such as x squared plus 4x plus 7 equals 0. So at the end of the semester, you learned how to solve this using factoring. And what factoring was opening a set of parentheses and figuring out what factors of a certain number added up to another. So we knew that x and x went here because x times x gave us the x squared. But then we knew that something times something had to give us this 7 here. So we looked for factors of 7 that added up to the middle term, which was 4. So factors of 7 are 1 and 7. Well, one of the things that I notice about factors of 7 is that if I subtract, I get 6, and if I add, I get 8. Neither one of them gives me 4. This means that this cannot be factorable. This cannot be factored. Okay, cannot be factored. So when we say that it cannot be factored, it doesn't mean that it can't be solved. And this is where the quadratic formula comes in. Basically, the quadratic formula is used to solve unfactorable, I think that's a word, unfactorable quadratic equations. That's where it's important. Okay, so let's go ahead and get started. The quadratic formula is used to solve quadratic equations, especially the ones that are not factorable. So we are generally solving for x. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. So when I look at this formula, it's very messy and very crazy, but the messiest part here, the hardest part, seems to be this part right here. That's actually where the discriminant lives. The discriminant is b squared minus 4ac. It's not the square root, but the stuff underneath the square root. Well, why is this important? Well, what makes the discriminant important is that it tells us the number of solutions our quadratic will have. It'll tell us whether it crosses the x-axis once, twice, or none of the time. Another thing that makes it important is it also tells us the type or the nature of the solutions. And when we say type or nature of solutions, it tells us whether or not these solutions are real, imaginary, or complex. So that kind of gives you a hint of why we've been talking about imaginary and complex numbers, is that quadratics are actually going to have a little bit to do with that. Okay? So let's go ahead and get into our first example. So let's start our first example. So our first example, I'm going to show you how to figure out what the discriminant is, what it exactly means, how many, and the nature of the solutions or the type of solutions, and what it will look like on the graph. So let's first start off by figuring out how do we determine this discriminant. Well, the discriminant is b squared minus 4ac. Well, if you notice, in order to figure out what the discriminant is or what the number is, I have to find out what a, b, and c are. Well, a, b, and c come from the quadratic equation. So remember, in standard form, it's ax squared plus bx plus c equals 0. So that tells me right there what my a, b, and c are. I know that a is 1 because there's a 1 in front of the x squared. I know that b is 10, and I know that c is 25. So what I'm going to do is I'm going to go ahead and plug that into my formula or my discriminant, which is going to be 10 squared for the b squared minus 4 times 1 times 25. If I put all that into my calculator, I get 0 as my answer. Okay. That tells me or means that my discriminant is 0. So what does this tell me about my solutions? It tells me that I have one real solution. And it also tells me that the solution is rational. Okay. Rational really basically means that you're either going to get a whole number or you're going to get a fraction. That's all that kind of really means. All right. How does this look on the graph? Well, if you were to graph this in your calculator, you would notice that it only touches the x-axis one time. That's the reason why it has only one solution, is because it touches the x or crosses the x-axis only once. Okay. All right, so let's try our next equation. All right, so once again, we're going to be finding the discriminant, and that's going to be b squared minus 4ac. I need to identify what a, b, and c are. So ax squared plus bx plus c equals 0. Alright, so I know that a is 6 because there's a 6 in front of the x squared. I know that my b is 1 because there's a 1 in front of the x. And I know that my c is negative 15. Why is it negative 15? Well, you have a minus sign or a negative in front of the 15. So you have to include it with the number. Now I'm going to plug this into my discriminant. So that's going to be 1 squared minus 4 times 6 times negative 15. When I type all that into my calculator, I get the number 361. So what does that tell me? Well, it tells me or means that my discriminant is larger than 0, meaning it's a positive number. It's bigger than 0. So what does this tell me about my solutions? What this tells me is I have two real solutions. Now, in this one, you're actually going to have two different types of solutions. You're going to have one that we call rational. We talked about that earlier. A rational solution is basically where you're going to have one number over another, or you may get a whole number. This is where your discriminant is a perfect square. So I'm going to use PS for perfect square. Then you can get a irrational real solution. An irrational real solution means that you have a non-perfect square, so I'm going to use PS for perfect square. And so you're still going to have the square root in your answer. So anytime that you have the square root still in your answer, it's going to be your irrational real solution. And so what does this look like on the graph? Well, what this looks like on the graph is that if you have two real solutions, it's going to cross the x-axis twice. So that's really important to know right there, is that it's going to cross twice. Alright, here is our last. Okay, so hopefully you tried this one on your own, and this is kind of where I got where I need for you to kind of stop. So once you find the discriminant, discriminant was negative 16, we learned that the discriminant, which is b squared minus 4ac, is less than 0. So what does this mean? What this basically means to us is that you have two complex solutions. Now, why is this so? Well, remember that the quadratic formula is x equals the opposite b plus or minus the square root of b squared minus 4ac divided by 2a. If you look at the b squared divided, or b squared minus 4ac, it is underneath the square root. Well, if you have a negative number underneath the square root, you're going to get an imaginary number or a complex number. So that's why you're going to end up having a complex solution. So what does this look like when we graph it? What this looks like when we graph it is that this quadratic is not going to touch the axis at all. It crosses a total of 0 times. Okay? So it doesn't cross. It hangs out there in the real and imaginary number line. So that's the reason why we do not get real numbers here, because it doesn't touch the real number line. So it's a complex number is its solution. So that's why we use the quadratic formula for this. Well, that's the whole set of notes. If you have any other questions, be sure to ask me when you start working on your actual work. Thank you.